Part of our risk management is to conduct what we call a risk analysis. And there are three methods that we're going to look at. Those methods are called the qualitative, the semi-quantitative, and quantitative risk management. Now, a qualitative analysis is often thought of a descriptive method of analyzing risk. Basically, this process is normally used with things like a checklist where we get a subjective rating. Now, what that means is we could say, okay, look, we're going to ask a series of professionals this question. We're going to say, we need to protect our web server from people trying to hack into it. And we can say, number one, you can tell me what do you think the odds or the level of risk is. Do you think that people are going to want to try to hack into our web server? And then here's a series of controls that we're thinking about using. Maybe firewall or Windows firewall or intrusion detection or something like that. And we're going to ask, out of those options, which of those do you think best is suited for this particular risk of somebody hacking into the web server? And we start giving them a rating value where they can come up and give us their opinion of what they think is, number one, the risk that it could happen, and which of these controls, if any, would be best suited for mitigating that risk. Now, that actually is a little more complicated than a simple checklist. A simple checklist could simply just be that, subjective ratings, odds of this happening, what do you think? Boom, write in a value, or yes you do or no you don't. What I also just described is kind of semi-quantitative, which is similar to the qualitative in that I have descriptive rankings, but in there I might actually create that numeric scale. So, now as I've got you looking at this chart, comparing the types of attacks and the types of controls and which do you think is best, and creating a numeric rating for you to put in, what value you think is better or worse for certain solutions. But again, it's subjective, because if you think about it, somebody who works in IT is going to probably have a different take on it than somebody who's going to be looking at the programming of the website, than somebody who's going to be in management who says, well, we need this web server, and yeah, I'd like it to be safe. We're all going to have a different point of view, and so it is very subjective as far as the rankings and the ratings that you might come up with. A quantitative analysis is actually using numeric values that can help describe the likelihood and the impact of risk. Now, those numeric values can come off of things like historic records, past experiences, industry practices and records, your testing and experiments that you've created. The thing is, I like to tell people that we can put hardcore, prices, values. Historically, we can say how often these things have occurred, and they can give us, hard information, not subjective information of what, this person thinks and what that person thinks, and we can use that, sometimes even in the benefit of trying to do a cost-benefit analysis of some of the safeguards and controls that we want to use. Now, the quantitative risk analysis is usually done through what we call the BIA, or the business impact analysis. One of the weaknesses, though, of this method is the actual valuation of an asset, as well as trying to quantify any ripple effects to the loss of that asset. What does that mean? Well, all right, let's say that I'm going to do a quantitative risk analysis about my favorite topic, right? You're going to all think I'm an arsonist or something, but it's just easy to relate, I think. The building that I'm working in, that my employees work in, my equipment, all that in there, has a vulnerability. It could catch fire. All right, so what's the value of that? Well, you can say, well, the insurance company and the real estate people have assessed the value of your building at $2 million. Okay, good. All right, I got a price. So now I can say, if I lost that, and remember we said that if the threat actually took place, that the damage done would be the impact. We can actually estimate what the impact of something like a fire would be. We can look at historical records and say, well, historically, a building of that type, construction made in that location, when it had a fire, we generally were able to see it contained because of the way in which it was made, the materials that was used, to a small portion of the building, maybe 5-10% of the building. So you're like, okay, so I know what the impact is potentially, and then you can say we see the records show that fires for your type of business and location and all this occur at this frequency, and so you say, okay, now I know how what the odds are that I'll even have one. And if I do have one, I kind of have an idea of how much will be lost. All right, so let's look at that. That you're going to say, all right, I've got all those really cool numbers, and I just kind of tied it in with what I just talked about. But here's the thing. Let's say you look at the value of the asset you're building, $2 million. Okay. If you lost 10% of it, you'd say, all right, I could lose, $200,000 worth of value, 10% of $2 million. But that's not the true value. Because now the problem we have is the ripple effect. The people that occupied that part of the building can no longer go back there to go to work until those things have been repaired. So the value you have in their production is lost. That production could limit your ability to deliver things to customers. So now you have customers who are at a loss, who may go to another company and find a new supplier other than you, right? So you got to remember that that makes it hard to value an asset. You really want to make it difficult. Go back to the information technology in this database of information where my stuff was stolen. What's that going to cause them? I mean, number one, they have to recreate the information besides trying to figure out how to make it more secure. They've got to get to all of us customers, probably liable for whatever cost it's going to take me to repair any damage that was done, right? So, the question is, if you had just said, okay, that data cost us this much in the man hours to be able to recreate, that's not the price of that asset. I mean, that might be the price to recreate it, or you might say, well, I've got it on backup, it'll be easy to restore, it won't cost us anything. No, you've got reputation, you've got the damages, the liabilities, so ripples, that's what I'm trying to get at. And so even though quantitative risk analysis sounds easy in theory, it is, I think, a lot harder to actually quantify the true value of an asset. Okay, in that discussion, I talked about the probability of expectancy. Now, that's a method based on classical theories, and even we know with things like earthquakes, tornadoes, natural phenomenon, we know that there's always variables that can affect the outcome and the probability that those events occur. But if we look over history, we can say, that in this region, a tornado occurs in the city once every 10 years, right? So we know that the likelihood of a tornado is like 10%, right? Every year, 10% chance. And that's what we do is we denote these events in the percentages of how that event occurs. Well, okay, so I say that's great. I remember being shoved into the basement of a hotel in Omaha because they had these series of tornadoes. And when we were looking at the online weather map where we were located in the city of Omaha, there were 10 or more funnel clouds shown in the graphic around our city. Okay, that you might have said, well, in Omaha, once every 10 years, there's a tornado. Okay, great. It just happened that year we had 10 of them all at once. And it was kind of crazy, kind of exciting, but it explains the point that even in natural phenomenon, there are a lot of variables that can affect these outcomes. So, you have to remember that a probability is just that. It is a chance that something can occur, but it's not, in complete, written in stone science that you're going to say, oh, I had one this year, so you're good for 9 years. Okay, it doesn't happen that way. But you can try to look at the historical rankings and add that into the quantitative part of our analysis.